Hello students. In our DME class, we were discussing about springs and this is the fourth part of the video. In this video, we will discuss two numerical problems. So let's see. Design a valve spring for the following operating conditions. Spring load when the valve is open 400 Newton. Spring load when the valve is closed 250 Newton. So actually it is a valve and it is open when the load is 400 Newton and closed when the load is 250 Newton. Maximum inside diameter of the spring 25 mm. Length of the spring when the valve is open 40 mm. Length of the spring when valve is closed 50 mm. Maximum permissible shear stress 400 megapascal. So this is the given data and we have to design the spring. Let's see the given data. W1 400 Newton. This is the load when the valve is open 400. W2 250. Inside dia 25 given. This is the inside dia. Length of the spring when valve is open, that is L1, it is 40, L2 50. Shear stress 400 megapascal or Newton per square mm. Mean diameter of the spring coil. First of all, we have to find the mean diameter. So let small d is the diameter of the wire. Capital D is the mean diameter of the spring coil. So capital D will be inside dia of the spring plus diameter of the wire. That is 25 plus D. Since the diameter of the spring wire is obtained for maximum spring load W1, therefore maximum twisting moment of the spring. So torque will be load into radius. So load is 400 maximum load and the radius is half of diameter, which is 25 plus D divided by 2. So this is your torque. And you also know the formula torque is equal to pi by 16 tau d cube, and put the value of shear stress and you can easily calculate diameter d, small d. So the wire diameter from the equation by hit and trial method will be 4.2, and now from the wire diameter 4.2 means you can see in this table the wire diameter is 4.2, so you will select 4.4 and your spring will be 7. So you will select the spring SWG7. Now let us find the diameter of the spring wire by taking Wahl stress factor into consideration. Now you will consider the effect of curvature, means you will apply the Wahl factor. So K is 4C minus 1 by 4C minus 4 plus 0.615 upon C. So C is D by D. So put the value of capital D 25 plus 4.47 divided by 4.47. So C will be 6.6. Now put the values to calculate Wahl factor K. So apply the formula for shear stress. Shear stress is equal to K AWC upon pi d square. Put the value of K, W, C, and you can calculate the diameter 4.5. Now you have two answers. One is 4.4, other is 4.5. So you will select the greater and your wire diameter will be 4.5. And again you will see the table. According to 4.5, you will select 4.8 SWG6. So your spring will be SWG6. So mean diameter of the spring coil, capital D is inside dia plus wire dia. So 25 plus 4.8, 29.877 will be your mean dia. Outside diameter of the spring coil, outer dia will be mean dia plus wire dia. So 29.877 plus wire dia, you will get 34.754. Number of turns of the coil. So you will calculate number of turns N by implementing the formula for deflection. So you can see that deflection will be 50 minus 40, 10, and load will be 400 minus 250. Well, that is 150. So apply the formula for deflection and you will calculate number of turns, because rest of the things are given in question. Modulus of rigidity is assumed, so number of turns will be 15. So for scare and ground ends, total number of turns will be, we have to add 2 and it will be 17. Free length of the spring, so you know that formula for free length is solid length plus maximum deflection plus clearance. So solid length is n dash d. You put the value of number of turns and diameter of the wire. Maximum deflection is here, from you can calculate. For 150 load, deflection is 10, and for 400 load, deflection will be 10 upon 150 into 400. So it is 26.67. Put the value here, and this is 0.15 into delta max. Put the value of delta max here, and this is your answer for free length. Pitch of the coil, free length upon n dash minus 1, and this is your pitch of the coil. So your next numerical, we will start. Safety valve of 60 mm diameter is to blow off at a pressure of 1.2 Newton per square mm. So you have given the valve diameter and pressure. It is held on its seat by a closed coil helical spring. Maximum lift of the valve is 10 mm. Design a suitable compression spring of spring index 5 and providing an initial compression of 35 mm. Maximum shear stress in the material of the wire is limited to 500 megapascal. Modulus of rigidity for the spring material is 80 kilonewton per square mm. So this is the given data. We have to calculate diameter of the spring wire, mean coil diameter, number of turns, and pitch of the coil. So how we will calculate? Valve diameter is 60, maximum pressure is 1.2, deflection is 10, spring index 5. There is another deflection given, 35 initial deflection, shear stress given, modulus of rigidity given. So how will you calculate diameter of the spring wire? So let's, small d is the diameter of the spring wire. We know that maximum load acting on the valve when it is just begins to blow off, that is load is equal to area into pressure. So area pi by 4 d square area, and pressure is 1.2. So this is the load. And maximum compression of the spring is, you have given two deflections, 35 and 10. So we will add them, that is 45. Since the load of 3394 Newton keeps the valve on its seat by providing initial compression of 35. Therefore, maximum load on the spring when the valve is open, that is for maximum compression of 45. So now this load is for the deflection of 35. For 35 deflection, load is 3394. And what will be the load for 45 deflection? So it will be 3394 upon 35 into 45. So the load will be 4364 Newton. Then we will calculate valve factor by applying the formula, and apply the formula for shear stress, which is 500 given to us, is equal to K 8WC by pi d square. So put the value of W 4364, which we have calculated. From here you will calculate the diameter of the wire, 12.06, and from the table you can see, you can select the wire size SWG7 having diameter 12.7. Mean diameter of the coil, we have to calculate C for that. C is given to us, capital D is equal to CD. So 5 into 12.7, 63.5. Now number of turns we can calculate from the formula of deflection, which is 45, and load is 4364, C cube N by GD. So from here you will calculate number of turns, and then you will add 2, because we assume scare and ground ends. Pitch of the coil, apply the formula free length, find the free length first, and then from the free length you can calculate pitch of the coil. So this completes the numerical. Okay guys, thank you.